Our next presentation is from Third Room, the Decentralized Virtual Worlds on Matrix. Robert Long from the Matrix.org Foundation is presenting today. Robert is the lead engineer on Third Room at Matrix.org. Previously, he worked on virtual worlds at Mozilla Hubs and at AltSpace VR. And he's a founding member of the Open Metaverse Interoperability Group. Please welcome Robert.
Hi everyone, my name is Robert Long, and this is Third Room. Third Room is a virtual world platform powered by the Matrix protocol, a decentralized and end-to-end encrypted communications protocol used for messaging, voice, video, and now 3D worlds. Here in the world, you can see my teammate, Nate Martin, joining us all the way from the US. Hey Nate, it's pretty late over there. Thanks for joining us.
Hey there.
All right, let's get into some of the features of Third Room. All right, so I'm going to open my overlay here, and on the left you can see some of the worlds that I can join. Here I am in the special SIGGRAPH version of an environment that we call Terra, and there's a number of other worlds that I can join, similar to how you might join a chat room. Each of these worlds can have their own environments and interactable content that I'll get into a little bit later. It's also still a full-featured Matrix chat client, so if I go into the Third Room chat down here, I can say, hello from SIGGRAPH. That's just the public chat room right there. All right, so Nate and I are communicating over a peer-to-peer WebRTC connection established over Matrix. Everything we do in this world is happening without any additional servers beyond our standard Matrix home server. Anyone with a Matrix account can use Third Room today. Anyway, this is SIGGRAPH, so let's get into some 3D stuff. So, Third Room uses a new browser-based engine, making full use of multi-threading through the new SharedArrayBuffer and Atomics APIs, now shipping in Firefox, Chrome, and Safari. In most 3D web applications, everything is running on the main thread, which leads to drop frames due to late WebGL submissions, stalling the UI thread when uploading textures to the GPU, and just a lot less room for adding fun stuff like physics and animations. So Third Room uses 3 threads, the main browser thread and 2 web workers. The first thread, the main thread, is running our React.js UI as well as our Matrix client, which handles real-time audio and game networking over WebRTC. The next web worker is running our game thread, which is running game logic, animations, and physics using Rapier, which is a physics engine written in Rust and compiled WebAssembly. And finally, our render thread, which is using a modified version of 3JS. Our game state is held in a lock-free data structure called a triple buffer, enabling us to run our game thread at a rate independent of a render thread. And in browsers where we can't easily limit our frame rate, this really helps us support high refresh rate monitors. Now let's get into some of the details of the scene. So we've got Nate's avatar running around the scene, building a tower over here. Either of us can spawn some physics objects and toss them around the world. Grab it right here. So to save on rendering costs, we're making heavy use of instancing. We have baked light maps in this scene and added support for reflection probes to 3JS. So if we go over here into this room, you can see the lights changing. It's all baked. So we added all this to 3JS, which gives us more accurate lighting for dynamic objects while we're moving about the scene, but still saving on expensive real-time lighting costs across the wide array of hardware we need to support. So in order to produce these assets, we created an export pipeline from Unity, which I'll flip over to now. You can see the same scene that we had open in Third Room. It's a standard Unity scene utilizing a kit from the Unity Asset Store. And if I zoom in here, I can see the reflection probe that we were just interacting with. And in the lighting tab over here, you can see the big light map for that scene. So this scene is exported as GLTF using the Unity GLTF exporter. We're not going to actually do this right now because it takes a little bit of time, but you can see the Unity GLTF exporter, which we use, and we built some custom GLTF extensions at Matrix, such as the light map and reflection probe extensions. We've also worked with other standards bodies, such as Chronos, and on the GLTF audio extension, and with the Open Metaverse Interoperability Group on a Collider extension. Back to the room in here. So after we've exported from Unity, it goes through an optimization process, which is a browser-based tool which compresses textures using the Basis Universal Texture Encoder and stores them in a KTX2 container. It also takes duplicate mesh references and converts them into instance meshes. It's really fast. So let's go and check out some other rooms. So Nate, let's head through this portal here on the left. Now here we are in the matrix in Matrix. Very, very meta, I know. Now if we hover over the TV, we get a tooltip to interact with it, and here we can see the code of the matrix. So this is just a simple interaction which we enabled through a high-level 3D API that we're calling Web Scene Graph. Let's take a look at the code which made this happen. So here you can see it's just a tiny piece of JavaScript where we're searching for the TV node and make it interactable, and then every frame we check to see if it's been pressed. When it has, we enable the matrix material. Now, the code for this behavior can be uploaded to any world in Third Room, and it'll be downloaded and ran on each client. Now, you might be thinking to yourself, wait, you're running untrusted code in an end-to-end encrypted chat app? This script is actually executed inside of WebAssembly's sandbox, which only has access to the Web Scene Graphs APIs we've exposed to it, making it a safe and secure way to run untrusted code for user-generated content. Let's take a look at one more example scene that's a little bit more advanced. So here you can see I can toggle the materials here between these two cubes, and if I go into this room over here, I can toggle the light switch over here. So let's look at the code for this. So this one is actually written in C. We're using WebAssembly, so any language that can compile to WebAssembly can be used to write programs for Third Room. So you can see we're looking for the buttons, and then every frame we check to see if they're pressed, and then we toggle the texture for the light values, or update the lights. So you can start to see we have full access to the scene graph imported by the GLTF scene. And if you've done any web development, this might start looking a little familiar. Just like JavaScript opened the ability to program bridge applications against HTML with the DOM API, we believe that Web Scene Graph has the potential to add interactivity to GLTF documents, allowing you to make portable 3D experiences such as games, telepresence, or advanced 3D apps that can be executed inside existing 3D applications or entirely new ones. So that's Third Room, the web-based virtual platform built on top of Matrix. Thanks, everyone.